This is lesson 10 warm-up, so take a second and do these problems, these two. We're graphing the solution of the inequality, so we need to solve it first and then graph it. So after a second we can do this. So on the first problem we're going to subtract 6 from both sides. We're going to get negative 2x is greater than 4. Then we're going to divide both sides by negative 2. When we divide by a negative, we need to reverse the inequality symbol. Make a note of that. We're dividing by a negative, we're going to reverse the inequality symbol. I would read this as all real numbers less than negative 2. All real numbers less than negative 2. Our graph, we're at negative 2. I don't have the equal sign, so I'm going to use an open circle. And then what kind of numbers are less than negative 2? Numbers to the left. Our next problem, we need to distribute. So we get 4x minus 3 greater than or equal to 2x plus 6. Let's get our variable on the left side, so I'm going to subtract 2x. Subtract 2x. If my variable is going on the left side, I want my constants on the right, so I'm going to add 3. And here I say I'm left with 2x is greater than or equal to 6 and 3 make 9. Divide by 2, divide by 2. So we have all real numbers greater than or equal to 9 halves. Well, what is half of 9? Half of 9 would be 4 1/2, so I've got 4. We've got 5. I could say here at 4.5. And we're greater than or equal to 4.5. I should change this to 9 halves. It's the same thing. So because I have the equal symbol, we're going to use a closed circle, and numbers that are greater than, 5 is greater than 9 halves, so we go to the right. Today's lesson is lesson 10, solving compound inequalities. So that's all you need to copy down, lesson 10, solving compound inequalities. So a compound inequality is an inequality connected by the words and or. If we were to graph this compound inequality, all real numbers greater than 0 and less than or equal to 4. So all numbers that are greater than 0. So what would that look like? Greater than 0. Greater than 0 would be open circle, and numbers that are greater than 0 go to the right. And less than or equal to 4. Less than or equal to 4. Well, less than or equal to means closed circle because it says it's got the equal to part of it, and numbers that are less than 4 goes this way. Now, any graph that goes in on itself, where from the left it's going to the right and from the right it's moving to the left, you can see they're going in towards each other. Any graph that does that is an AND statement. And this is exactly how I'd read this. All real numbers greater than 0 and less than or equal to 4. So this is an AND statement. Now, how would I write this inequality? When we write these inequalities, we start in the middle. All real numbers greater than 0, so we move to the left. And, so then we go back to the middle, and less than or equal to 4. So again, I read this as all real numbers greater than 0 and less than or equal to 4. So why don't you guys do this one? First, let's graph it. All real numbers that are greater than or equal to negative 2 and less than 3. So I can just say, okay, well, we've got negative 2 here. And greater than or equal to negative 2. So that would be, because it says or equal to, we're going to use a closed circle. And numbers that are greater than would go to the right. And then it says and less than 3. So negative 2, negative 1, 0, 1, 2, and 3. And less than 3 doesn't have the equal sign, so I'm going to go open circle, and less than goes to the left. So now how would I write this as an inequality statement? My numbers are negative 2 and 3, so I can just write this in. Negative 2 and 3 are my numbers. I put a variable in the middle. Greater than or equal to negative 2 would be greater than or equal to. All real numbers greater than or equal to negative 2, and less than 3, I'd eat the 3. All real numbers greater than or equal to negative 2 and less than 3. Our next example, solving a compound inequality with and. So here we've got this inequality, but we don't have our variable by itself in between the symbols. So I want to be able to isolate or get this variable by itself. So normally we think of an equation having two sides. Now we've got three sides. I've got a left, I've got a middle, and I've got a right. I want to end up with my x here in the middle, and an inequality symbol, and an inequality symbol, and we'll have solutions on either side. So here's what we want to do. We're just going to ask ourselves what we always do. What's happening to our variable? Our variable is being multiplied by 3 and it's being subtracted by 8. So we want to undo the subtraction first. Since we have three sides, I'm going to add 8 to all three sides. And I get 6 greater than or equal to 3x here, less than or equal to, and 8 plus 10 is 18. Now what's happening to my variable? It's being multiplied by 3. So we're going to divide all three sides by 3, and I get 6 divided by 3 is 2. 3 divided by 3 simplifies out, that's how I have my x, and 18 divided by 3 is 6. So now I would read this again from the middle. All real numbers greater than or equal to 2 and less than or equal to 6. So I could say if this was 2, I'm greater than or equal to 2, so greater than or equal to. With the or equal to, I'm solid circle. Greater than goes to the right. 3, 4, 5, 6 would be right here. 6, and I'm less than or equal to, so or equal to means solid circle, and less than goes to the left. So now what does this mean? This means that all my solutions are in between these 2 points, including the number 2 and including the number 6 because of the or equal to. We include 6 and we include 2. We include 6 and we include 2. Let's look at this other one from example 1, our previous one. Our solutions are everything in here. Now, if we look at the left side, we're including, that includes the number negative 2, but it doesn't include the number 3. Why doesn't it include the number 3? Because the number 3 has just the open circle. It's just less than 3. It's not including 3. It's not or equal to. So that's how we tell the difference. That negative 2 is a solution, but 3 is not a solution, but any number in between those is. So you guys try doing this one. So here we're going to subtract 3, and subtract 3. We've got all three sides. I've got negative 8 greater than or equal to 2x less than 4. Divide by 2, divide by 2, divide by 2. Now the other day I said if we divide into a negative, we flip the symbol. No, that is not right. It's if we divide with a negative or multiply with a negative. Here we're dividing into a negative, but we're not dividing with a negative, so we leave the symbols how they are. We leave them alone. Leave them alone. So negative 8 divided by 2 is negative 4. Simplifies, and 4 divided by 2 is 2. We'd read this. All real numbers greater than or equal to negative 4 and less than 2. My numbers are -4 and my number is 2. Greater than or equal to would be a filled in circle, a closed circle we call it. And greater than -4 goes to the right. Less than 2, less than, open circle, less than goes to the left. This is still an AND equation. So here is an OR equation. Now 99% of the time the ORs you'll be able to tell because it will say the word OR. So let's do this. We're going to solve it. Subtract 1, subtract 1. I get 3x is less than 3. Divide by 3, divide by 3. X is less than 1. That's part of my equation. I'm going to add 5. I'm going to add 5. I get 2x is greater than 12. Divide by 2, divide by 2, and x is greater than 6. So here we have all real numbers less than 1, and then or all real numbers greater than 6. So we would write these numbers down. I've got a 1 here. I've got a 6 here. If I want to be all real numbers less than 1, we'd go open circle, and less than 1 goes to the left. All real numbers greater than 6, open circle, going to the right. And this is why this is called an OR statement, because the solutions to this type of equation would be either the numbers that are less than 1 or they're numbers that are greater than 6 out there. They're not numbers that are in between. They're not solutions of both of these. Because you can't be less than 1 and greater than 6. You're either one or the other. That's why it's called an OR statement. So the OR graphs go away from each other. So let's try 2. Write an inequality that describes each condition. Water is a non-liquid when the temperature is 32 degrees Fahrenheit or below. So we'd say, okay, well, if I were to make a graph, I'd say 32. When it's 32 or below, that would mean I'd want to include the 32, because it says 32. Or below, that would mean going to the left. Or is at least 212. So I've got 212 out here. At least means that I'm equal to, or I am, if I say I'm at least as old as you are, I'm as old as you are, or I'm more old than you are. I'm greater than your age. So this would be considered an OR statement. Now how would we write this? We'd write this as all real numbers less than or equal to 32, or all real numbers greater than or equal to 212. That would be how we'd write that inequality. Example 4, reversing both inequality symbols. So I've got this -2 symbol, -2, -x symbol here. So what are we going to do? We're going to work our way backwards through our order of operations. So I can see I'm subtracting 2, so I'm going to add 2. I'm going to add 2, and I'm going to add 2 to all three sides. -2 plus 2 makes 0. -2 plus 2 makes 0 again. So I'm left with a -x in the middle. 1 plus 2 makes 3. This -x means -1 times x. So what undoes that? We're going to divide by -1. Divide by -1 and divide by -1. When we divide by a negative, please remember to reverse your inequality symbols. -1x divided by -1 leaves you with just an x. 0 divided by anything is going to be 0, and 3 divided by -1 is -3. So now we might look like we're done, except we aren't done. What we want to do from here is we want to rewrite these so that they're going from smallest integer to biggest integer. So -0 is bigger than -3. So I want to rewrite this with my negative 3 first and then my 0 out here. I'm leaving my x in the middle, and now we're just paying attention to what we did. Between the 0 and the x, what were we eating? We were eating the 0, so we're going to go back and we're going to make sure that we were eating the 0 again. Between the negative 3 and the x, we were eating the x, so I'm going to go back and I'm going to eat the x. And now we'll graph it like this. Our numbers are negative 3 and 0. We are greater than, all real numbers greater than negative 3, so that's an open circle, greater than, goes to the right, and less than 0. And less than 0. The important thing when we divide by a negative that we are reversing the inequality symbol and then rewrite it from lowest integer to highest integer. So this looks like an OR statement already because it gives it away because they say the word OR. So what are we going to do? We're going to add 5 and add 5. 6x is less than 12, divide by 6. X is less than 2. Subtract 1, subtract 1. 8x is greater than 24, divide by 8. X is greater than 3. So here we've got, our numbers are 2 and 3. We are less than 2. Open circle going to the left. We are greater than 3, open circle going to the right. So this is an OR statement, so I write the word OR in between. All real numbers less than 2 or all real numbers greater than 3. So my solutions again are numbers that are bigger than 3 and numbers that are less than 2. Are we including 2 and 3 as a solution? No, we're not, because we don't have equal signs with our inequalities. We can tell graphically because we're using an open circle. So our homework is page 10 from our packet. Get on getting on.